We will be discussing how to clear check install on your submeter, and specifically power factor and how that relates to the class 1000 and 2000 series meters. Did you rule out no load or light load, making sure that you have at least 2% of your meter rated amps per phase? Meaning again that if you had a 200 amp meter, you would need at least 4 amps per phase, or on say a 100 amp meter, you would need to have at least 2 amps per phase. You also want to make sure that you have proper phase rotation. The meter does require right-hand rotation, and on the class 2000 you must have 3-phase power to the physical meter. The class 1000 series may be a single-phase meter. And also pertaining to current sensor installations, make sure the sine waves to the line voltage must match identically with the proper current sensor. So we need to make sure that we're actually monitoring the correct loads. If our B CT sensor or current sensor is on the B location, we need to make sure that we're actually monitoring the B circuit. If this is still continuing to be an issue, we want to look for things that could give you a poor power factor. Certain types of loads could definitely contribute to having a poor power factor, such as nonlinear loads like fluorescent HD lighting, arc welders, solenoids, induction heating equipment, small quote-unquote dry pack transformers, or induction motors. All of these can cause you to have a poor power factor, and if you do feel that you might have this in your location, you may want to speak with your building engineer or a power quality engineer to look at why the power factor is low in your building. Please follow us at HoneywellDiscoveryTraining.com for more how-to videos.